Okay, today we are going to create a line of best fit. As you can see, got a couple of different sets of data here. So the data can either be corresponded or correlated positively, like that one, negatively, like this one, or this one was like all over the place. So we're going to talk about the types of data that can be correlated. So we're looking at a set of data down here, and we're going to call this a line of best fit. So move this down a little bit, and what we're doing here is computer saturation in America from 1984 on. So you're looking at numbers of the percentage of households that have a computer from 1984 to 2003. I know it's 17 years later, but we're still going to use this set of data. So the first thing you'd have to do when you see something like this is you're going to want to change the years to numbers that are a little bit easier to work with. So for instance, right here, instead of 1984, we're going to call that year 0. And then since 1989 is 5 years after that, that's a 5. 1993 is 9 years after that, that's 9. 1997 is 13 years after that, that's 13. 2001, that's 17 years after that. And then 2003 is 19. And what I did is I took the liberty to graph this already. So I graphed each of the points, and you can see that it is a line of best fit. It doesn't fit exactly. So I have a couple of points above and a couple of points below, but it doesn't fit exactly the points because not all the points line up. So what we're going to do is find the equation of that line. And in order to do that, we need to pick a couple points on the line, not necessarily points from the data, but points on the line. So the 2 points I am going to use are 312, which is right here. So 312, oopsies, used the wrong one. Let's undo that. 312, and let's use a different color than purple so it stands out. 312 are around here. And the other point we're going to use is 15, right here, 15, oh, 50, okay? At this point, we find the slope just like you learned many, many years ago. So 50 minus 12, subtract the y values, subtract the x values, 15 minus 3, so it's 38 over 12, which can be simplified to 19 over 6. Okay. At this point, we're going to use the slope and just one of the 2 points. I'm going to use 312 because it's smaller, a little easier to work with. So I'm going to use the slope, point slope formula. I'm sorry, slope intercept formula. And we're going to use this one right here. So 12 equals my slope, which is 19/6 times 3 plus b, which I'm trying to find. So 3 goes into 6 twice. So we got 12 equals 19 halves, which is the same as 9.5 plus this b value. Okay, subtract 9.5. And I get b is equal to 12 minus 9 is 3 minus another half is 2.5. So my equation is going to look like this. Y equals my slope, which is 19/6 x plus 2.5. And what we're trying to do is find out how many computers or what percentage of households would have computers this year, which is 2020. So 2020 It's 1984. Basically, just think of it this way. If somebody's born in 1984, how old would they be in 2020? In this case, it would be 36. So now I'm going to do 19/6 times 36 plus 2.5. So 6 goes into 36 6 times. And then 6 times 19, so 6 times 10 is 60 plus 54 will be 106.5% of the household. That is not reasonable, can't be more than 100. But you kind of get the idea. Think about it. It's 2020. Probably everybody has a computer or pretty close to it. Now remember that this predicts, it's not an accurate representation. So that number probably is a little smaller. I mean, I would say probably somewhere in the 90%. So you can probably look it up on the internet. So this would be a best fit line. That's it.